Hey class, let's do one more video before we take our quiz on Tuesday. This one is going to be about the quiz review, which I gave everybody on Friday. So hopefully you were working on it. You should have it by tomorrow, and then you'll have a chance in class tomorrow to ask questions. You can watch this video tomorrow night to get any last minute tips and tricks, but for now, let's go. So we're starting here. We're given that quadrilateral QRST is similar to quadrilateral MNOP. And then they're just asking you to list the corresponding sides, which again, you know, it would be nice if you could do it just by looking. When I look at this, I can see that the two figures definitely want to reflect onto each other, meaning N right here is going to go with R, and O is going to go with S, and P is going to reflect all the way over onto T. And then M is going to go with Q. So you should be able to see that, right? Usually you can. Sometimes you can't. Sometimes it's harder to tell. But for this, I think you can. But let's say you couldn't. If you couldn't and you're wondering who Q corresponds with, well, Q is first and M is first. So you know that Q goes with M. And now you know that the two figures map onto each other by a reflection, not by a translation. If it was a translation, then M would map onto R. Not by a rotation either. If we were rotating, then M would probably rotate onto T or something. But anyway, none of that makes, you know, any difference because you've got your similarity statement to give you all these answers, so it should be cake. So we're going to say Q goes with angle M. Make sure you include the symbol for the angle. Then we'll probably just do R, which is going to be congruent to N. I'm going to do S, which is congruent with O, and then T, which will be corresponding with P. I think in there I was saying congruent to, as opposed to corresponds with. Luckily for me, it's the same. They do happen to be congruent. Even though the triangles are only similar, the angles are congruent, while the sides are proportional. So the sides certainly aren't congruent. But in terms of who corresponds with who, we can see that QR is going to correspond with MN. You do need the hat on top. So they said QR. Let's do RS now then. And RS is going to map onto NO. After RS, we'll do ST. And ST is going to map onto OP. Okay. I just had some weird window pop up. I don't think you guys saw it on your side. I don't know, some error in my computer. Looks like I'm still recording though, so I think I'm okay. Alright, and then finally we have QT. QT, which maps onto MP. That's it. That's it for all my pairs of corresponding parts. Now they're wondering if R is 43, that's this guy. So if that guy's 43 degrees, then what's N? And as we just were mentioning, when angles are corresponding to each other, they also end up being congruent. So it's 43 degrees. Again, if we were talking about sides, they would not be congruent. They would be proportional. There'd be some scale factor, but that's it. So this says complete the proportions. So we've got MN, that's this guy, over QR, that's this guy. So that's a pair of corresponding sides. Then they've got NO. And we know that NO corresponds with RS, so that's what should go down here, RS, and that would complete that proportion. Over here, I see the TQ. TQ is this guy, which corresponds with MP, or PM, whatever. So that's good. So now we've got ON. No, we already used ON. ON goes with RS. So here the numerator must be RS. That's kind of a silly question. Both of these were RS. Whatever. Moving on to 2. So here we're being told that these triangles are definitely similar. I'm going to make this a little bigger. A lot bigger. So we're told these triangles are for sure similar. What's the scale factor? And you guys, I think by now, this must have sunk in. That scale factor comes from just comparing any two corresponding sides. So it's got to be the 6 with the 15. Now they're asking for the scale factor, but we actually have no idea which one is the pre-image or the image, So this would be one of those times where you might want to say that your scale factor is 6 over 15 or 15 over 6. We don't really know which. But either way, if I'm giving 6 over 15, do make sure you simplify. They're both divisible by 3. So you get 2/5. So 2/5 would be 0.4. Then we could say, or, you know, if we're going the other way, if we're trying to shrink this, we'd use the 0.4. But if we're trying to expand this, we'd use the 5 over 2. And that would be a scale factor of 2.5. So depending which way we're going, maybe my scale factor is 0.4 or maybe it's 2.5. So here's a better question. It says the measure of angle A is what? So A is blank, and A would correspond with F, but F is blank. So to try to find A, we've got the 65, but then nothing. But then, aha, here's the 28. So we can take the 28 for angle D and say that angle C corresponds with D, so this is 28. And then we can use the 65 and the 28 to solve for A. So we're going to say what? That angle A plus the 65 degrees plus the 28 degrees equals 100, excuse me, 180. Because a whole triangle always adds up to 180. So adding 65 and 28, I get what? 6, 7, 8, 93? Yeah. So subtracting 93, we find out that A is 87 degrees. And by the way, that does mean that F is also 87 degrees. All right, now they say write and solve a proportion to find X. So we did a bunch of these already. We know we're going to use the 6 over 15 again. We're solving for X, and we can see that X corresponds with 8. So to write our proportion, we sure as heck have to use the ratio that has X in it. So X over 8 is definitely one of our ratios. Now X over 8, that's a measurement from the big triangle divided by small, so big over small. So I could either go 15 over 6, or I could grab this reduced version from part A when we found our scale factor. We could just say 5/2 if we wanted to. Although I'm inclined to maybe just stick with the 15 over 6 to remind you that all we're doing is grabbing that other pair of sides from the triangle. But yeah, I mean, we can make the math easier here by dividing by 3 and just having a 5 over 2. This is just going to make the math easier as we cross multiply. So 2 times x will be 2x. And 5 times 8, like I know that's 40. 5 times 15, maybe I don't know what that is. But 5 times 8, that's 40. And then we see we can divide by 2 to get 20. So x should be 20. And then we do the same thing to solve for y. And for y, we can see that y corresponds with 10 over here. So we can go write our cells of proportion. And okay, let's say we put y in the numerator, 10 in the denominator. Then suddenly we don't want 15 over 6 anymore, because y over 10, we're now doing small over big. So we'd want 6 over 15. But again, the 6 over 15 would be 2/5. So I'm just going to slide in the 2/5, keep the math easy for myself. So when I cross multiply, I get 5y, and I set that equal to 20. I'm going to divide by 5 to get 4, and that's it. 4. I want the 4 over here. I don't know why I put a box around it over here, but whatever. Anyway, there's your 2 answers for number 2. Let's move on. Okay, so more of these overlapping triangle problems. These always make me nervous. You know, here I just think the temptation is going to be for someone to set up a proportion where they just go 6 over 8 equals 12 over x, and that's just going to be completely wrong. So don't do that. Let's pull the triangles apart, relabel them like I've been telling you to do, and you'll see why this is wrong. In the small triangle, this is definitely 6, that's 8, that's easy. This is x in the big triangle. And then, well, this side down here it's not simply 12, it's 12 plus 6. The whole side should be 18. So as soon as you see that, you can see that in our little proportion, the 6 over 8 was fine, but it should have been 6 over 8 equals 18 over x. So that's where we went wrong. And again, I don't even do it that way anyway. I'd compare the 6 to the 18 because those are corresponding. I'd compare the 8 to the x because those are corresponding. So we're going to end up with the proportion 6 over 18 equals 8 over x. And I can reduce a little, so I will. I can factor out actually a 6 to be left with 1, factor out a 6 to be left with 3, and we're done real fast. If you reduce that fraction, we're done like immediately because 1 times x is x, and then 3 times 8 is 24. And that's it. The answer is 24. So moving on to the next one. Am I concerned? Here I'm not as concerned because they're giving me the total length of the side. So if I pull these triangles apart and relabel them, I get one that's 12 with an x. The next one's 36 by 24. Those happen to be the numbers I was looking at anyway, right? So you need to be concerned when one of your sides is split into two pieces, because one of those pieces doesn't belong to any triangle. It's just a part of the triangle. So you kind of need to make sure you redraw them. Make sure you do the 12 plus the 6, you get 18, then you don't look back. You forget about the 12 and you stick with the new values. But over here we're good. We're good to go. Our proportion is going to be 12 over 36 equals x over 24. And in case this is the only video you're watching, I'll mention again that yes, I know that it's obvious that 12 times 3 made 36. So if you understand scale factors, you know that x times 3 has to make 24, which means x has to be 8. Yes, I can do that math in my head too. But doing math in your head doesn't get you credit on the quiz. So make sure you don't pull any stunts like that where you just write down x equals 8, because you're not going to get credit. Like, I mean, let's say this is 3 points. If this was 3 points, I'd give you a point, I guess, for getting the right answer, but I'm for sure taking 2 points away, and I'm flagging you for not showing work, and that's, that's not good. So make sure you show the work. I know that this math is going to typically be easy. I'm doing that on purpose, by the way, right? I'm giving you easy numbers so that the numbers aren't what you're stressing over. But you got to show me that you know how to do the math, right? You need to know how to set it up to get an answer. So I'm doing you a favor by giving you numbers that are easy enough that you don't need to show the work. So you gotta do me a favor and show me the work anyway. Okay. So anyway, showing the work means setting the proportion up like this. Now again, if you want to just reduce this, you're gonna make your own work a lot easier because this will go down to 1/3. Then you end up with 3x equals 24. You divide by 3 and you get that 8. And now you've shown me that you know where that 8 comes from. If all you did was write down x equals 8, I got to sit here and worry about whether you just looked at somebody else's paper and got 8 that way. That's why we show our work in math class. It's an honesty thing. It's also just a thing where you're proving to me that you really know how to do the math, like the right way. All right, let's move on. Number 4. So here's one of those, it's kind of like the word problems that we were doing before. It says, which triangle congruence criteria tells you that the triangles below are congruent? Well, let's see. I'm going to go ahead and assume that, what even is this, 9? I don't know. This is not a great word problem. Normally you're trying to find the height of the flagpole or something and you're using something else, but whatever. So the flagpole forms a 90-degree angle with the ground. Whatever this is forms a 90-degree angle with the ground. So that gives me a pair of congruent angles. You could make that weird argument I was trying to make in class where these angles are congruent because the light rays of the sun are parallel, something like that. The safer bet is just to say that this angle right here is an angle that the two triangles share, right? So you got these angles, you got these angles. That gives you angle-angle similarity. So these particular triangles can be proven similar by angle-angle similarity. So I'm just now noticing this is a massive typo. We should be saying which triangle similarity criteria tells you that the triangles below are similar. There, that's better. Anyway, it's angle-angle. So to solve I'm not going to be as careful as I was for the past couple problems. I'm not going to pull these triangles apart. I can see the 9 corresponds with h, so I'll set up one ratio that's 9 over h. And then I don't see that 12 corresponds with 28. What I see is that 12 corresponds with the whole side, which is going to be 40, so it'll be 12 over 40. Again, you don't have to pull the triangles apart. If you've done enough practice problems by now that you get this, you know, by all means, just get it done. I can reduce this, right? They're certainly divisible by 4. I would get 3, and I would get 10. Yeah, that's the best we can do in terms of reducing. Now, cross multiply. 3 times h will be 3h. And that'll be equal to 10 times 9, so 90. Divide by 3. H is going to be 30. With word problems, I would want you to make sure to use your units, but there's no units here. But pretending for a moment that these were all feet, 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 then this would be feet. So just, you know, fill in the units if they're there. Number 5. It says for each pair of similar triangles, use triangle similarity to solve for x. Okay, I will. So I know for a fact that these triangles are similar. So who corresponds to who? Well, we've got the 90 to the 90. We know that this angle is congruent to this angle by the corresponding angles postulate. So that seems to say what you all probably assumed, which was that the 14 corresponds to the 24, and x corresponds with 60. So this problem should be pretty straightforward. We'll just plug in our two ratios. We've got 60 over x, and that will equal 24 over 14. So cross multiply, you'll get 24x, and 60 times 14 is, I don't know, why didn't I take my own advice and reduce when I could? This should really just be 12 over 7. Can I do that math in my head if I reduce? I can. Because I get 12x, and 60 times 7 I know is 420. So from here now I can try to divide by 12. And I get x equals whatever 420 divided by 12 is. Can I do that in my head? Yeah, it's 35. Right? Yeah. Yeah. Uh-huh. Yeah. Okay. All right, moving on. Let's do this one. So again, who's going to correspond here? Well, the fact that these angles are congruent tells me these triangles are kind of rotating onto each other. So yes, 11 would be corresponding to that guy over there across the way. The 22 is going to correspond with the x. So this one seems pretty standard. You'll just plug into your proportion and solve. So if I'm going small, this is another one. Oh no, this is fine. So 22 over x is small over big. And then 11 over 54 would be small over big. So I know we've got this set up right. Can't reduce anything this time, so we're going to just have to know what 22 times 54 is. That's a shame. I don't know what that is. So we'll bring back the old calculator. Move it over there. Okay, so we're trying to do 22. Whoops. 22 times 54 is going to be 1188, apparently. And that's going to equal 11x. So if I divide, what's that going to be? 108? Must be 108. So let's divide by 11. Yeah, 108. All right, easy peasy. So if you divide by 11, you can get those 11s to cancel, leaving you with x, and then this gives you 108. So that's how long this side is, 108 units. Okay, what about 6? So another kind of word problem. Again, I see right angles. So those are just a gift. We can say that those right angles are congruent because they're both right angles. And then the other one that we see so often, we see these angles right here, and we know those are vertical angles. So again, we can say that these triangles are similar because of angle-angle similarity. And now it says use that similarity to find the distance d across the stream. Okay, fine. So we know that the 25 is what corresponds with d. We know that the 21 corresponds to the 15. So we just write a proportion. Sure, let's take our variable. We can say d divided by 25. And we know that's got to be equal to the 21 divided by 15. Alright, I do see that I can reduce, so I will. These are both divisible by 3. So if I divide by 3, I get 7. If I divide by 3, I get 5. That's going to make life a little simpler. So d times 5 is 5d. And 25 times 7 is 175. And I realize I'm leaving the calculator up. Let's put that away. And here's all that work I've been showing. So our proportion again was d over 25 equals 21 over 15. Both of those were divisible by 3, so I did that, and I get 7 over 5. Then cross multiplying, I get d times 5 equals 7 times 25, which is 175. So lastly, we just divide both sides by 5. And we get d equals, let's see, 5 goes in 3 times. Leaving 2, so 35 is the answer again. We got 35 just a couple problems ago, didn't we? Yep. C. Alright, whatever. 24, 14. Yeah, different numbers. Just happens. Alright, let's do 7. So for 7, 8, 9, 10, maybe even 11, 12 too, we're supposed to be proving that these triangles either are similar or aren't similar. So this first one, I see a pair of congruent angles, so that's great. But then I see an 81 and a blank space. And then I see a 67 and a blank space. So I need to solve for one of those blank spaces and hope that maybe they're equal. Because if I can get 2 pairs of angles congruent, then we'll have our angle-angle similarity. So let's solve. Let's say that, angle E plus the 32 plus the 67 has to make 180. Again, all triangles add up to 180. So this means angle E, angle E plus 99 equals 180. So you subtract 99 from both sides and you do get 81. So that means angle E is 81, and we knew that angle C was 81. So we can now say, are they similar? Yes, we know that they are. If so, what's the similarity criteria? It's the angle-angle similarity postulate. So name the triangles. I'll go ABC. Anytime I can just say ABC, I'm going to do it. Now, ABC, we're going blue, purple, pink. So the other one's going to have to be blue, purple, pink. So it's going to be FDE. And that's it. You just want to make sure you list your corresponding parts in the right order. So when we say A first, we have to say F first because those are corresponding. When we say B second, you got to say D second. That's just the way it is. All right, next pair. I'm looking at these. Among my sides, 30 is the smallest. And over here among my sides, 6 is the smallest. So you know you want to pair up the smallest with the smallest. Then the biggest is 50 and the biggest is 12, so pair them up. And then you need the mediums too, because it looks like for this problem, we're going for side, side, side similarity, which means we need all the ratios to come out the same. So let's start with 50 over 12. I can chop both of those in half to get 25 over 6. That's the best I can do. It's going to be 25 over 6, whatever that is. Then I get 30 over 6. Well, I can chop that in half. I'm going to get 15 over 3, which is 5. 5 is not the same as 25 over 6. So we don't even need to check the orange ones, although we can check it really easily. 40 divided by 8 is 5. So the orange and the blue are proportional, but the pink is throwing everything off. Which means we can say beyond the shadow of a doubt, are they similar? No. If so, state the criteria, not applicable. Name the similarity thing, we'll say not applicable. Then it says, if they're not, then explain why. We can just say the sides are not proportional. And if you're going to say the sides are not proportional, if you're kind of keeping it simple like that, then just make sure you have the work that proves it. We can show that this is not the same as 5. There's our proof. So next, 9. 9 is showing a pair of vertical angles. That's good, but those are the only angles we get. So that must mean we now have to rely on the sides. And it looks like this is going to be a side angle side situation. So again, of the two, 28 and 24, 24 is smaller. Then 36 and 42, 36 is smaller. So you know you want to compare 24 to 36 and 28 to 42. So okay, just set up those fractions and see what they're worth. 24 over 36, those are both divisible by 12 to give 2/3. So 2/3 is the ratio that we're trying to match here. We're going to try a 28 and a 42. And I can see those are both divisible by 7. Divide by 7, you get 4. Divide by 7, you get 6. Now those are still both divisible by 2. And that lands me on 2/3. So that proves that those two angles, or those two pairs of sides, are proportional. Don't forget, you better talk about these angles too. I'm going to name one of them 1 and the other one 2, and then we can say angle 1 is congruent to angle 2. And you can say by the vertical angles theorem. And then you can say, are they similar? Yes. If they are, then what criteria? Well, we just used side angle side, because we proved that we had two pairs of sides, that were equal in ratio, so they're proportional. And we had the one pair of angles that was congruent. Those occurred right between them, so that's what side angle side looks like. Then we'll name these. I do see ABC, so I'm going with that. Then I see that A must correspond with E, so we're going to go E first. Then we went ABC, so we got to go EDC. And that does it. If not, explain why. That's not applicable. All right, another one. This is looking like it's a side, side, side. My smallest side is the 13. Here my smallest side is 39, so we'll put those together. My greatest side is 18 and 54, and my middle sides are 15, 45. So let's just check our ratios, see what happens. We're going to go 13 over 39. And 39 is, when you divide 13 out of it, you get 3. So if I factor out 13, I get a 1. If I factor out 13, I get 3. So 1 to 3 is the similarity ratio we're looking for. I'm grabbing the red sides. Did I just do that? Yeah, grab the blue then. You'll go 15 over 45. And again, these are both divisible by 15. I do get the 1/3. So far so good. Grab the greens, you get 18 over 54. Those are both divisible by 9, I can tell. So divide by 9, you get 2. Divide by 9, you get 6. And now I see I can divide by 2 again. So I do get 1/3. So there's the proof. I've shown that all three ratios give 1/3. So are they similar? Yes. What's the criterion? Side, side, side. Similarity. And then name the triangles. Well, the first is going to be ABC. And then the second one, since we whipped around ABC, well, let's see. We went through the red side first and then the blue. So up here, I guess we got to go EDF in that order. That's it for 10. I think there's a couple more of these. Yeah, so we'll keep at it. How's this one gonna go? So we can say for sure this angle is congruent to this one because they're vertical angles. But the 53 and the 52, those are not the same. And that's going to throw the rest off. So the 35 doesn't really have a chance of being congruent with this one either. So this is going to be another. Are they similar? You'll say no. If so, you'll say not applicable. Triangle congruent statement, you'll say not applicable. If not, explain why. You'll say, not all angle pairs were congruent. Or are congruent. So we did have the vertical angles, but then the 53 and the 52, they were off. The 35 and whatever this turns out to be, they'll be off too. So since we don't have all of our angle pairs congruent, we can't be similar. And then lastly, I see vertical angles again. And then I see sides again. And among those sides, I see 23 is the smaller. So we're still just working across the point of intersection. It's going to be 23 with the 67. It's going to be 27 with the 81. So let's check our proportions, see how we do. If we go 23 over 67, 23 I know is prime, so you can't break that down anymore. And 27 and 81, you can't break that down anymore, but it's not equal to the one in blue. If you don't believe me, we'll do it in the calculator just to be sure. There it is. Excuse me for yawning. 23 over 67. Divide those. You're going to get that decimal, 0.3432835, blah, blah, blah. If we do 27 over 81, though, it's probably going to be close, but it won't be identical. Yeah, it's 0.3333333. So that's really darned close. But close isn't good enough. So we're just going to say no. Okay, so where it says, are the triangles similar? You'll say no. You'll say not applicable. You'll say not applicable. And you'll say the sides are not proportional. All right, that's it. Just a few more. Oh yeah, this one's easy. In a similar triangle, the corresponding angles are, you're going to say congruent. In similar triangles, corresponding sides are proportional. I've said this so many times, so you guys know this already. Two more. We're going to do a couple of dilations in the coordinate plane. It says A prime, B prime, C prime is a dilation of ABC. That means we're going from big to small, so this is a contraction. You might make a note of that. And the reason you might want to make a note of that is because now when we go to do our scale factor, we'll know whether to put the big number on top or the small number, because small over big, that's always going to be less than 1. That's always going to be what we want for a contraction. Now if our dilation was an expansion, then we would need to be doing big over small, because that would be a number greater than 1. That's going to be our expansion. So with all that in mind, how do I do this? Because I don't know how to find the lengths of any of these diagonal sides. On all the homework questions, you guys had like right triangles just chilling in the coordinate plane, and you could just find the length of the vertical edges by counting how big they were. You just went 1, 2, 3, 4, that's 4. And then you count the boxes over here, 1, 2, that was 2. So then your growth factor was by a scale of 2, right? 4 over 2 made 2. So we don't have that idea here. I can't really find the diagonals. So we know that we can just use the coordinates. Like, what are the coordinates of A? Well, they're left 2, so negative 2. And then they're down 1, 2, 3, 4, 5, 6, 7, 8. Now find the coordinates of A prime. It's only left 1, so negative 1. and then down 1, 2, 3, 4. So just looking at the coordinates, we can see that the coordinates of A have just been chopped in half to give the coordinates of A prime. So that's your scale factor, 1/2. If we do the -1 divided by the -2, the negatives cancel, you get 1/2. So to write a coordinate rule, very easy. You just take whatever your scale factor is and you multiply that by x. Then you take your scale factor and you multiply it by y, and that will generate all the new points on your image. All right, just the one more. So okay, this time we're going from something small and going out to something big. So this is an expansion. What's my scale factor? Again, I don't see anything flat or horizontal, but I do see that A is at -2, -2. I also see that point A maps onto point A prime. And I see that A prime is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So -6, -6. So just from that info alone, I can see that my coordinate rule is that we're multiplying by 3. That means we're in expansion. It also means our scale factor is 3. We're blowing everything up by a factor of 3. So the one thing missing from this, it was missing from the last one too, but nobody actually asked you for the center of origin or the center of dilation, sorry. So we can't do any of this if we don't know the center of dilation, but it's probably obvious to you guys. We would connect B prime to B, we'd connect C prime to C, and look where all these lines are going, straight to the origin. So the center of dilation for sure is the origin, which is good, because if it wasn't, we wouldn't know how to write our coordinate rule. But that's it. You now know basically everything. Yeah, that's the end of the road. So if you watch these videos, you should be able to ask me a lot of very interesting questions on Monday, and you should be ready to go on Tuesday. So thanks a lot, guys. Have a good night. I'll see you tomorrow.